Okay, fall mock final for 2020. Okay, so here's number 1, which is multiplying imaginary numbers. So what I would do first is I would probably multiply these first. So negative 5i times I, you guys, is negative 5i squared times 7 minus 2i. Now, recall, this is the information we know about i's, right? These are just things that you guys should know. I is I squared is negative 1, I to the third is negative I, and I to the fourth is 1. So, since we have I to the second power, we need to change that so that it's negative 1. So, we're going to have negative 5 times negative 1, because I squared is equal to negative 1 times 7 minus 2i. So negative 1 times negative 5 is just simply 5, and we still got 7 minus 2i, and then we just have to distribute. Okay, 5 times 7, 35, 5 times negative 2i, negative 10i. So your guys' answer for this one should have been C. Okay? Guys' answer for that one should have been C. Okay, so here's number 2. When you guys do this, you gotta multiply by the conjugate. So the conjugate of this, you guys, is when the denominator's I is the opposite. So 7 plus 3i. Now, recall, when you guys multiply by the conjugate, just this, right? That's the only thing that's the conjugate. All you guys have to do is just do 7. 7 times 7, the first two, and you just have to do negative 3 times 3i. Remember, that's only how you multiply for the conjugates, right? Because the middle terms cancel. Okay, 7 times 7 is 49. Negative 3i times 3i is minus 9i to the second. And we'll change that I to the second later. Okay, on top, different story. You gotta distribute twice. So gotta multiply 1 to both of these. And you gotta multiply negative 4i to both of those. So 1 times 7, 7. 1 times 3i, 3i. Negative 4i times 7 is negative 28i. And negative 4i times 3i is negative 12i to the second. Okay, moving on. Alright, I'm going to change my I squares. I know this I squared is negative 1, right? And I know this I squared is also negative 1. So, I'm just going to rewrite this. 7 plus 3i minus 28i. Okay, negative 12 not times negative 1 now, which is plus 12. 49, and then write negative 9 times negative 1 is positive 9. Now just simply collect like terms. So on the numerator, 7 plus 12 is 19. 3i minus 28i is minus 25i, all over 58. And the only one that has that appears to be B. Okay, so there's number 2. Okay, number 3. This is your guys' quadratic formula. So we have to move everything to one side. So I'm going to subtract 8 AP and minus 13 to go on the left-hand side. It's so that we set it equal to 0. So we're going to get 4p squared. We moved the 8p to the left-hand side now, so it's going to be negative 8p, because, right, these cancel. And we subtracted 13 from both sides, so we have that. Alright, so remember, we have it in standard form, so this is A, this is B, and this is your C. I wrote that down because this is the formula. Negative B plus or minus square root of B squared minus 4AC all over 2A. Alright, so we know our A and B and C. Now we just have to plug them in. So we're going to have minus -8 plus or minus -8 to the second power minus 4 times A, which is 4, times C, which is -13, all over 2 times 4. Okay, simplify all that. We're going to get 8 plus or minus -8 squared is 64. -4 times 4 times -13, you guys, is plus 208 all over 8. Simplifying more, 8 plus or minus square root of 272 all over 8. Okay, so right now we need to simplify this to root 272, you guys. So I'm going to do it over here. Okay, so 136 times 2 is that. I know that could be split into 2, so that is 78. Oh, nope, sorry, 68. 34 and 2, and 17 and 2. So there's a pair, and there's a pair. So that means those get to come on the outside of the root, right? Each pair. So we get 2, because that represents one pair, and 2 represents the other. And the leftover is 17. So root or radical 272, you guys, simplifies to 14 root 17. So equals 8 plus or minus, back to this, 4 root 17 all over 8. Okay, so do you guys see this 8, that 4, and that 8? All of those can be divisible by 4. So I'm going to divide top and bottom by 4. And you guys, you should get 2 plus or minus square root of 17 all over 2. So when you guys look at your answer, the only one that has 2 plus or minus square root of 17 all over 2 appears to be this one, A. Okay, number 4. Okay, move everything to one side, right? Set it equal to 0, so minus 4v from both sides. That's going to be gone, right? So we're going to have 4v squared minus 4v plus 7 is equal to 0. Okay, I'm going to label A, B, and C. And let me just drag this over here so that you guys have the formula. You don't want to erase. There we go. All right, here we go. Substituting into our equation, so we're going to get -4, because b is a -4, plus or minus -4 to the second, minus 4. A is 4, and C is 7. All over 2A, which is 4, 2, 4. All right, simplifying, you get 4 plus or minus 16, 28, 7 times 4 is 28, 28 times 4 is negative, 56, double that, 112, all over 8. Simplify that more, negative 94, no, 96, all over 8. So now we gotta simplify that one, right? So I'm gonna do it on the side. Okay, well remember, just when you guys have a negative on the inside, that's really square root of -1, which is just I. So I'm just going to take the I out so that it's positive inside the square root. Now let's get this, 48 and 2, 8 and 6, 4 and 2, 3 and 2, and 2 and 2. So here's a pair there, here's a pair there. So that means I know one set of 2's comes on the outside and another. And remember, there's still an I out there. Square root, leftovers, the 3 and the 2, so that means 3 times 2 is 6. So 4i root 6. That's the simplification of negative square root of -96. So 4 plus or minus 4i square root of 6 all over 8. And recognize, right? Boom, boom, boom. 4, 4, and 8 can all be divisible by 4. Divide by 4, divide by 4. So 4 divided by 4 is 1, plus or minus. 4i divided by 4 is just I. And 8 divided by 4 is 2. So which one of these dudes looks like that? Looks like to be that one. So that's B. Okay, moving on. All right, so look at this. Looks to be 4 terms, right? So this makes me have a hunch we can factor this by grouping. But first, I am noticing I could probably factor out a number from each one of these terms. So 6 can go into all of those. So 6, I'm factoring out a 6 from each term. 60 divided by 6 is 10, p to the third. 30 divided by 6 is 5, p squared. Negative 84 divided by 6 is 1, 14, p. And negative 42 divided by 6 is 7, -7. Alright, now we can get into our factor by grouping the first 2 terms and the last 2 terms. So I'm going to put the 6. I'm just going to leave that alone for now. Now, from the first set of parentheses, right, I can see I can pull out a 5 and a 2 and p squared. So 5p squared. So we're going to get 2p plus 5p squared divided by 5p squared is just 1. Now, the second parentheses, right, I'm noticing I can pull out a -7. Usually, you guys, you don't like to see a negative in the front. So, -7, -14 divided by -7, 2p, -7 divided by -7, plus 1. Now, take a look. Both of these parentheses are the same, so that means you guys can distribute a 2p plus 1 from both of them. So we're going to get 6, 5p squared minus 7 times 2p plus 1. Answer looks like C. Okay. 6. Alright, right off, I can see that I could factor out a 5 from each term. So, 45 divided by 5 is 9, b to the 4th, minus 20 divided by 5 is 4. Okay, I'm noticing we could use this formula right here, the difference of squares. Because I notice there's a minus sign, and I'm noticing there's 2 terms, and in both terms, you could probably square root both of these. Or not probably, you can square root both of them. So 5, the square root of 9b to the 4th, you guys, is 3b squared. So write that twice. The square root of 4 is 2. So 2 and 2, plus and minus. So remember, to recognize this, you guys, 2 terms a minus sign in between them, and if they are both, you could take the square root of both, and they come out pretty nicely. So there you guys go, and that looks to be D. Okay, 7. Factor out a 2, that looks to be the choice. 27, 54 divided by 2, 27, x to the third, plus 16 divided by 2 is 8. Now, this is what I'm noticing. 2 terms, and both of them, you could cube root both of them. So this automatically makes me think of this formula. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And you guys also have this that could approach too. This is what you guys call the sum and the difference of cubes. And something I always told you guys is to use SOAP for an acronym. Same, opposite, always positive, to remember the sign. So if you know it's positive, right? Same, opposite, always positive. Look at this sign, right? If it was minus, then same sign, opposite sign, always positive sign. Alright, so let's cube root both of them. So 2. The cube root of 27x to the third is 3x, plus cube root of 8 is 2. Now, this is really our a, right? This is really our a value, and this is our b. So, following the formula, right? A squared would be 3x to the second power, so 9x squared. Negative ab would be negative 3x times 2, which is just 6x. And b squared would be 2 squared, which is 4. Looks to me, it looks like C. And you guys could check this, right? Because it has a 2 in the front. You know it has a positive, since that's going to be positive, and 3 terms, right? Okay, number 8. Factor out a 2. So we're going to get 4p to the second minus 25. Okay, I'm noticing 2 terms, and there's a negative sign, and they both look like you can square root both, so this reminds me of the difference of squares. So 2. Square root of 4p squared is 2p. Square root of 25 is 5. Plus, minus. D. Okay, 9. Perform the function. So recall, you guys, that this notation means f of g of t. So we know what g of t is, which is just f of g of t, you guys, is right there. So oopsies, too big. 4t minus 3. Now, this tells me, right, let's put this as our input. So let's insert 4t minus 3 into the f function and put it wherever you guys see it t, or substitute it. So what we're really going to get is, we're going to get 4t minus 3 to the second power, right? Remember, this t, you guys, is now 4t minus 3. So squared plus 4. So remember, 4t minus 3 to the second really looks like this, right? Gotta multiply it to itself twice. And then you guys gotta distribute, right? Just like this. So 4t times 4t is 16t to the second. 4t times negative 3 is minus 12t. Negative 3 times 4t is negative 12t. And negative 3 times negative 3 is 9. And do not forget the 4 plus 4 equals 16t squared minus 12t is negative 24t. And 9 plus 4 is 13. Okay, and that looks to be D. Okay, 10. So, this notation, g of f of 9, sorry. G of f of 9. So, work inside and out, so we gotta go find f of 9. Well, if we use this information right, f of 9 looks to be 9 squared plus 4 times 9. It looks to be 81 plus 36, which is equal to 117. So it's really going to come out to g of 117. Now this tells me to substitute 117 into the g function up there. So I'm running out of room, but g of 117, you guys, right? Oh, I'll just write it back there. Sorry. G of 117 is really 117 minus 4, which is simply 113. D. Okay. 11. Alright. G of h of negative 3. So I need to substitute a negative 3 into the h function first. So h of negative 3 is equal to 4 times negative 3 plus 5. Negative 12 plus 5, negative 7. So this is g of negative 7. Now this tells me to substitute negative 7 into the g function right there. So g of negative 7 is equal to 3 times negative 7 minus 3, which equals negative 21 minus 3, which equals negative 24. That's my answer. Okay, moving on. All right, so this is standard form, a quadratic function in standard form. So might as well go ahead and find the vertex, which is negative b over 2a. Let me label, this is a, b, and c. So we got negative 4 all over 2 times 2, negative 4 over 4, which is negative 1. So that gives me my x value of my vertex, but now I need to go find my y value. And to find my y value, I just have to substitute negative 1 into my original equation. So negative 1 squared, you guys, is just 1, so 2. Negative 1 times 4 is negative 4 plus 4, and that's simply going to be 2. So I know my vertex is negative 1 and 2, and you guys see how that 2 is positive. So if a is positive, that means it's going to open up. Smiley face. Okay, it's going to give you a smiley face. So let's look for a graph that has a smiley face and has a vertex at negative 1, 2. It doesn't look like it's A, and it looks to be B. And you guys see that it has a vertex at 4. This one also has a vertex. Not a vertex, sorry. Y-intercept at 4. B. Okay, 13. Now, this has vertex form, okay, you guys? So this is what vertex form looks like. Your guys' vertex is this. Now notice that this is a positive h, right? In this formula, you just have to take that h value, regardless, well, okay. So even though that says minus h, remember that this is just h. So kind of like the opposite of what you guys think to some degree. So in this one, I know the vertex to be 3, negative 1. The vertex in that equation, you guys, is 3, negative 1. If it said x plus 3 squared, then it would be negative 3, negative 1. Okay, now see that negative sign? That means your a is less than 0, which means you're going to have concave down, a sad face. So let's look for one that's concave down and has a vertex of 3, negative 1. That one does not. Sad face, but that vertex is not at 3, negative 1. Sad face. Oh, sorry. What am I looking for? Oh, yeah, 3, wait. Three, negative 1. Yeah. Sorry, I got tripped up. Nope. This one, 3, negative 1. Yep, D. Alright, moving on. Okay, 14. So, one thing to notice is for these, it's always good to find your guys' possible rational zeros. That's your P over Q list. So, this is your guys' P, and this is your guys' Q. So, P over Q is equal to, okay, the factors of P is plus or minus 1. The factors of Q's is plus or minus 1 and 3. I need to 1 and 3. Okay, so now you gotta divide 1 over 1 plus or minus 1. 1 over 3 plus or minus 1/3. So let's go down the list and see which one at least have the same P over Q list. Okay, this one looks good, so we're gonna keep that for now. This one, that one's not even the same. Cross that off. C looks good, and D looks good, okay? Now, remember about the, this list, you guys, is your guys' rational zeros should come from this list right here as well. So when I look at these rational zeros, negative 1/3 and 1 comes from here, so that looks to be good. Now, do you guys see these? That one says rational zeros of negative 1/3 and negative 2, but negative 2 is not even in that list, right? So I'm going to eliminate that one. And when you guys look at D, do you see how it says it has zeros of rational zeros of 0 and negative 1/3? Well, 0 is not even part of that list, so that's gone. So then this one is the only one that seems to work. And of course, if you want to make sure, you guys can test these ones by doing synthetic division, and then you guys should get remainders of 0. Okay, 15, we got P over Q. So factors of P is plus or minus 1 and 2. Factors of Q is plus or minus 1 over 2. So 1 over 1 plus or minus 1, 2 over 1 plus or minus 2, 1 over 2 plus or minus 1/2, 2 over 2 is 1, we don't need to rewrite it again. So again, let's just look at our list to see which one doesn't have our possible rational zeros list, our P over Q list. This one does not, it has that. This one looks good. This one looks good. And this one looks good. So we know A is not the answer. Now let's look at our rational zeros, right? Because our rational zeros should come from this list as well. So here we have this. Negative 3 is out of place. So eliminating that one. Here it looks good. Negative 1 and a negative 1/2. Those are both in our list. And over here, sorry, you guys can't see the list anymore. All of these look good because all of those are in our P over Q list. So the only thing we have to look at is these, right? Our possible number of real zeros. So to find your possible number of real zeros, you look at the highest degree and you keep on subtracting by 2 until you get to negatives. So our highest degree is 3, which means we can have 3 possible zeros, or you guys keep on subtracting by 2. So 3 minus 2 is 1, and we're going to stop there because 1 minus 2 will give us negative 1. So this tells me our number of real zeros, 3 and 1. So that means it is D. Can't be that one. Okay, 16. Now, this end behavior, you guys, I'll write down a list for you guys. Positive even, negative even, positive odd, negative odd. Those are all your guys' end behaviors. And to do your guys' kudos to you, student, who showed me this, and you know exactly who I'm talking about. Alright, so, okay, see this x to the fifth, you guys? So it's a positive and it's an odd. So that means since it's positive odd, we're going to have an end behavior that goes like this. Positive odd looks like that. So that means when you guys do this on the graph, it's going to look like that. So that means as x goes to infinity, f of x has to go to infinity. As x goes to negative infinity, f of x has to go to negative infinity. So this means we are looking for, so as x goes to infinity, f of x went to infinity, which is this one. As x went to negative infinity, f of x went to negative infinity. So we gotta look for that one. So the only one that looks like that, negative and infinity. So it's A. Okay. We'll do the same thing over here. So if you look at your guys' end behaviors, it's negative and it's an even. So that's down and down. So if you guys made this chart, this is infinity, positive infinity, negative infinity, negative infinity. So since it's down, down, it looks like this, right? So as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. I don't like that. Get it back, get it back. Alrighty, there we go. Okay, so that's what we got. So now let's go find that. So x is infinity and f of x is negative infinity. So x infinity, negative infinity, and negative negative. Oh, that is also going to be A. Okay. Alright, so here's 18, you guys. So to find, so we know that these are zeros. So we got x equals negative 4/3, x is equal to negative 4/3. It's twice because it says multiplicity of 2, which means there's 2 zeros at that location. And x is equal to negative 3/2. Now, to put all these in polynomial form, we don't like fractions, so we have to multiply and try to get rid of the fractions. So for the first two, multiply both sides by 3. So we're going to get 3x equals negative 4, 3x equals negative 4. And for this one, multiply both sides by 2. So we're going to get 2x is equal to negative 3. Gotta set it equal to 0 so we can get it in polynomial form. So that means, I'm going to rewrite over here, we're going to get 3x plus 4 times 3x plus 4 times, oops, I wrote 4 right there, but that should be plus 3. 2x plus 3 equals 0. Now what you guys would have to do for this is, oh man, sloppy. We would just have to distribute this, okay? So I'll do these two first. Actually, I'll do these two first. So you would have to do that, and then you would have to do that, right? In order to find your polynomial. So 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x, and 4 times 4 is 16. Combine like terms, so you would get 9x squared plus 24x plus 16 is equal to, plus 2x plus 3 is equal to 0. And then you guys would have to distribute this to all of them, and this one to all of them. So 2x times 9x squared would be 18x squared. 2x times 24x would be plus 48x squared. 2x times 16 plus 32x. 3 times 9x squared would be plus 27x squared. 3 times 24 would be plus 78x. And 3 times 16 would be plus 48. And all of this would equal 0. So you guys would have 18x squared plus 75x squared plus 110x plus 48 is equal to 0. So that's what your polynomial would be. And for you guys, that would be, that's not good because it looks like I made a mistake somewhere. So wait, where did I make my mistake? 3x times 3x, 9x squared. 3x times 4, that looks good. Okay, that looks good. That looks good, so where did I go wrong here? 2x times 9x squared. Oh, first of all, I think I'm just going too fast. 2x times 9x cubed. 24, 32x good. 27. Oh, there we go. That should be 3 times 24 should be 72. There we go. Alright, sorry for that. So 104x plus 48. And the only one that looks like that is this one. Now, this is how you guys can check your work, right? To check your work, I would just make one of those zeros and just do synthetic division. So if we were to pick C, we have 18, 75, 104, and 48 as our coefficients. Now this is where I told you guys to do MAMA, right? Multiply, add, multiply, add, multiply, add, multiply, add. Acronym MAMA. So when you guys multiply 18 times the fraction, just divide it first by the numerator and then multiply by the, divide first by the denominator and then multiply it by the numerator. So 18 times negative 3 is okay. 18 divided by 2 is 9. 9 times negative 3, negative 27. Add that and we get 48. 48 times negative 3 halves would be 48 divided by 2, which is 24. 24 times negative 3, negative 72. add that, and you would get 32. 32 divided by 2 is 16. 16 times negative 3, negative 48. And that's good enough proof for me, right? That's good enough proof to show that that is going to be a, that 0 is a 0 for that function. And right, if you want, you can test out all of A through D, you guys, to see which one would give you a remainder of 0 for synthetic division. Alright, this one, we know our zeros are 5, 4, and negative 1. So I'll go in reverse. So first, I would just test out one of these zeros to see if it would work out for any of these. This is what you guys could have done in the previous problem as well. So I would just test out like negative 1, and then I would just look at A. So this is letter A, and I'm seeing if this letter A would give me a remainder of 0. Negative 1 times 1, negative 1. Negative 5 times negative 1, negative 6. Negative 6 times negative 1, 6. That add to the 17. That times each other, negative 17. Well, this does not give me a remainder of 0, which automatically means this one cannot be that one cannot be a choice because negative 1 isn't a 0 for it. So then, right, you guys would just go down the list and see which one would give you a remainder of 0. So mama, right? 1 times negative 1, negative 1. Add together, negative 9. Multiply together, 9. Add together, 20. 20 times negative 1, negative 20. So that one doesn't either. So for C, we get coefficients of 1, negative 8, 11, and 15. Well, I already know this one's not going to work because these had the same first 3 coefficients, but then, right, 21 didn't work because it was going to give us negative 20. So that means it's going to be not that one, but D. Now, that's if you guys just want to guess and check all that stuff. Now, if you guys want to solve for it, this is what I did in number 18. This is what I'm going to do for this one. So you know all your x's are that. So that means to get these all set to equal 0, it'd be subtract 5 from both sides, subtract 4 from both sides, and add 1 to both sides. So here are my polynomials that I would multiply. So x minus 5 times x minus 4 times x plus 1. Set that equal to 0, or the function, right? Okay, so I would just do this first. You could do it the other way too, you guys. You could go from right to left. X times x, x squared. X times negative 4, negative 4x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is 20. All times x plus 1. So we're going to get x squared minus 9x plus 20 is times x plus 1. And then you guys would just distribute this one to all of these for both. So x times x squared is x to the third. X times negative 9x, negative 9x squared. X times 20 plus 20x. 1 times x squared, x squared. 1 times negative 9x, negative 9x. 1 times 20 plus 20. X to the third minus 8x squared plus 11x plus 20, which also would have given you guys D. Alright, so for here, you guys, this graph gives you information. So, first of all, this gives you guys what your end behavior is. So negative, even, a negative and an even, which would be down, down. And I'm looking at this, which is my y-intercept is 0, negative 2. So let's look for a graph that goes down, down, and gives us a y-intercept of negative 2. That one does not, because the y-intercept's 2. This one does not, because that's a y-intercept of 4. This one does not. Oh, this one does, because it has a y-intercept at -2. So, C. 21. Okay, it's a positive and it's an odd. So positive odd, you guys, is down and then up. That's what the end behavior looks like. So you could have automatically eliminated that one because it's the only one that goes up and then down. And the y-intercept for this one is 0, -19. So A has a y-intercept right there, right at 3. So that can't be it. This one's possible because -19 would be way down here, right, for the y-intercept. D, this one has a y-intercept -3, so it can't be that one. So it has to be C. Okay, last one, last set of 2, and then I'm gonna do it in the other video, you guys. I'm gonna make this a 2-part video. Alright, so when you guys are finding rational expressions and adding them, we gotta get the same common denominator. So this one is missing v minus 6, so I need to multiply top and bottom by v minus 6. This one is missing the v plus 4, so I gotta multiply top and bottom by v plus 4. So that means this 2v, you gotta distribute it to both of them. And this 5v, you gotta distribute to both of them up top. And then the denominators would be the same. So v minus 6, v plus 4, because they're both gonna give you the same denominator. So 2v times v is 2v squared. 2v times 4, 8v. Now we gotta do this side. 5v times v is 5v squared, and 5v times -6 is -30v. These are the same, and those two that I did not highlight are the same. So you can combine like terms. So 7v squared, 8v minus 30v is minus 22v. All over the same common denominator. So your answer, B. 23. Okay, so this one is missing this denominator, right? So that means to get the same common denominator, we need to multiply top and bottom by x minus 1. And on this side, this one is missing this denominator, right? So to get the same, we gotta multiply top and bottom by x minus 6. Sorry if it looks weird. Alright, so on the top, you gotta distribute this to both of these, right? Now, do you guys see this negative sign? So I would just attach this negative to that 3, okay? So it's -3 times that and -3 times that. Do not forget that, because some of you guys won't distribute that, so then you guys won't get the same correct answer. So we're still gonna have x minus 6, x minus 1. 5 times x is 5x, 5 times -6, -30, -3 times x is -3x, -3 times -1 is 3. So these are the ones that have the same like terms. So 5x minus 3x, 2x, -30 plus 3, -27, x minus 6, x minus 1. So this concludes the first part, and I will have the second part up shortly. Peace.